All right, gonna let, once again, let the buffering and the Twitch stuff catch up with us. Um, Make sure levels are right and things look good. All right, more or less. Okay, so this week is going to be the flyweight pattern. Um, we're more or less following our MUD-Z game phases and milestones. So we did the factory pattern, the strategy pattern, the bridge pattern, the command pattern, the state pattern. And now, to finish up phase 2, we're into the flyweight pattern. And like we saw with the state pattern, we're starting to reap the benefits of a good foundation of decently followed design patterns and some consistency in the way we architect our project has allowed for further patterns to kind of just slip right in. And we're going to find, when we look at the game later, that we've actually already used the flyweight pattern in some areas. We just didn't call it that, and we maybe didn't use it as, say, effectively as we could, because the real power is definitely shown once you get to have larger collections of things. That being said, let's go ahead and find a definition for the flyweight pattern. I like this one. Use sharing to support large numbers of fine-grained objects efficiently. So this is a very light definition. Let's see if we can get just one more. Anyone will do. Some programs require a large number of objects that have some shared state among them. Consider, for example, a game of war, where there is a large number of soldier objects. Soldier objects maintain the graphical representation of a soldier behavior, etc., etc. All right, so on the one side we had a definition that was maybe too sparse, and now we have one that might be a little too specific. So I'll compare two patterns, and hopefully that'll give us a little bit of context. So when we did the strategy pattern and the bridge pattern, we found they were very similar, and the difference came in the implementation details and some of the semantics and specifics. We're going to find the same thing as it refers to the factory pattern and the flyweight pattern. So the factory pattern, if you remember, was one that we wanted to be able to separate the creation of an object from its implementation. And if we go back to the code kata for that, so our very first kata was pretty simple. We created some enum types for our switch statement. We created some POCOs, and then we just let it fly. So we said, hey, create new type, and we got back an object. So this time, what we want to do is that very similar pattern in the sense that we want to go to a central class, a context, and we want to ask it for something. And we want, in order to phrase that request, we want to give it as little information as possible. So with the factory pattern, we gave it a type, it ran off and created something and gave it back to us. Now we want to give it a key, and then we want it to go through its trove. Think of a library archive, right? It's going to give it the ID, it's going to run off, it's going to grab the thing that already exists and hand it back to us. So, let's go ahead and write this kata from scratch. So to do, as always, we create or burn a Git repo. Let's go ahead and add that card. So over here on GitHub, I'll come back into my account. I'll do new repository, and I'll say flyweight pattern kata. C# example of the flyweight design pattern. I'll initialize a README, and I'll create the repo. So there we go. And then all I need to clone this repo in Visual Studio is this link. Click over to Visual Studio. I'm going to say open from source control. I'm going to say, come back over here to connect to team projects, which gets me back to the screen where I can select whether I want to go from Visual Studio Online. I already have some Git repositories defined. I'm going to clone a new one. I'll then just paste in my address, and I'll hit clone. So this is cloned, and then if I go into the Flyweight pattern that now appears in my list, under Solutions, it'll be empty. So I'm just going to create a new solution. It's going to be a console application as always, and I'm just going to call this Flyweight pattern kata. I'm creating a C# project. Sometimes when you first open Visual Studio, it likes to switch you over to VB. I've been burned by that a few times. Not a huge deal, but if you're waking up and you're doing a design pattern kata and you're like, hey, I got 15 minutes before work, let me just do this mental exercise, every minute counts. So, having to delete and recreate a project because it was in VB, not the most fun in the world. All right, so there we are. So you created our repo, and we'll come back over here. All right, so let's go ahead and add a few more cards before we mark this one as done. So for the Flyweight pattern, let's go back over to an example. We're just gonna pick a different one every time. Here's one for Java. So it reinforces the benefits. Need to create a large number of objects because of the large number when memory cost is a constraint. Yada yada yada. Okay, here's a UML. So the UML is a Flyweight factory that contains a collection, a method called getFlyweight, some interface, a client, and a concrete Flyweight. So let's go ahead and simplify this way down into terms that we've already been using. So we always need to start with some sort of thing as our example. And because I'm really leveraging domain-driven design, I want that to be a domain aggregate. So if I think that my thing is going to be a car, I want my overarching thing to be a vehicle, and that's what I'm going to make my abstraction based off of. I want to get as low level as possible, that lowest common denominator. And then for my next step, I need to create an abstraction for this pattern, right? So I need to say, what is the thing when combined with my object that's going to create the behavior I want, right? That's the abstraction. And then my thing, truck, for example, or vehicle, will either derive from or implement that contractor abstraction. Nothing new here. I'm just slowing it down and kind of going through piece by piece what the kata does. But the fun part and the rewarding part is that these are all terms that we've been using for the last 5 weeks. So they should seem pretty familiar. Every single time we're starting a Git repo, every time we're selecting a domain aggregate, every time we create an abstraction that represents the functionality or the contract that we're using with our pattern. All right. So and after these 3 steps is where the pattern should differentiate. You typically have a context for everything, which is usually your application. But we're just gonna, in this case, we're gonna go and specify it. Back in the definition, they call this the Flyweight factory. It doesn't necessarily always have to be that. It can be anything that encapsulates this collection of items and gives you a way to access them. So, say, select, create a context. And, oops, let's come back over here. And let's modify this to say, with a method to access the Flyweight collection. That's kind of the biggie there. Okay. And then, so now we've got an abstraction. We have a context. And now all we need to do for the last step is to create some concrete flyweights. I'll make that a paren, just in case we just make one. One or many flyweights. And then we're going to say wire it all up. And our last stop is always to profit. Maybe. Okay, so we've succeeded in creating our Git repo. Let's hop back over to Visual Studio. Oops, I forgot a step. I apologize. Create a simple UI. Terribly, terribly important. We want to make sure we're creating a last known good, or that we have a kind of last known good state for our environment. But I'll go ahead and check this in first. Commit. Create or burn Git repo. And sync that up. All right, so it's out there on GitHub now. And let's go ahead and move this above. All right, so next step is to create a simple UI. All right, so as usual, we're going to say console.writeLine, hello world, console.read key. All right. Then we're just going to go ahead and play that. All right, hello world, it works. It reads the key and exits. Can't ask for more than that. Okay. Done that. All right, and then select the domain aggregate. So, in the past, we've tried to pick something that's going to lend itself to extension and have a few members. This is going to be super simple. So, let me go ahead and add a folder called domain. And I'll pick the tried and true example of animal. Okay. I'm just going to add a new class here called iAnimal. Am I getting ahead? No. We're going to make this a public interface. So public string, oops, no access modifiers in interfaces, so just string name, get, and set. So every animal is going to have a name. That's really all we care about, right? And then we'll say that every animal can also string speak as a function. Doesn't take anything, it just speaks. All right, so let's go ahead and check that in. And commit it and sync it up. All right. So, for the abstraction, this is where the flyweight pattern becomes pretty simple in the sense that we can use an existing abstraction. We don't need to go off and make something new. We don't have to go out and architect something crazy. We can say, you know what,